Hello friends, today's question. It is found that if a neutron suffers an elastic collinear collision with a deuterium at rest, fractional loss of its energy is Pd, while for its similar collision with carbon nucleus at rest, fractional loss of the energy is Pc. The values of Pd and Pc respectively are. So here the neutron first make a collision with deuterium, and in the second case it makes with the collision with the carbon. So let us consider the case 1, in which neutron collides with deuterium. So this is our neutron having a mass m, and let us suppose it is moving with a velocity v0, and this is our deuterium d, and its mass is twice that of neutron, so this will be 2m, and is it at rest, so its velocity will be 0. And after collision, suppose neutron is moving with velocity v1 and deuterium is moving with the velocity of v2. So this is our mass m, and this is also mass 2m. So this is before collision, and this we have after collision. So we can use momentum of conservation, and conservation of momentum before collision and after collision momentum will be same, so this will be m into v0 plus 2m multiplied by 0 will be equal to m v1 plus m v2. Here the mass going to cancel out throughout, obviously this will be 0, so we can write the equation as, this is 2m, so we get the equation as v1 plus twice v2 is equal to v0. Let this be equation number 1. Now it is given that they suffer elastic collision. So you can say for elastic collision, the coefficient of restitution, that is E, for elastic collision E is equal to 1, and the formula for E is the ratio of relative velocity after collision and relative velocity before collision. You can say relative velocity after collision and relative velocity before collision, and this will be equal to 1. So relative velocity after collision will be equal to v2 minus v1. So we can say v2 minus v1 divided by before collision is v0 minus 0. This is equal to 1. So from here we can write the equation as v2 minus v1 is equal to v0. This is equation number 2. So we can use equation 1 and 2 using equation 1 and 2. We get Let me write equation 1. Equation 1 was V1 plus twice V2 equal to V0, and equation 2 was V2 minus V1 is equal to V0, and if we add them, V1 cancels out, so we get this as thrice V2 is equal to twice V0, or from here we can find out that our V2 will be equal to 2 by 3 times V0, and we can find out V1 also. So we can use, suppose using equation 2, equation 2 is V2 minus V1 is equal to V0, so this will be 2 by 3 V0 minus V1 is equal to V0, or from here we can say that our V1 will be equal to minus 1 by 3 V0. Now it is said that the loss of energy for the neutron is given as Pc. We can find out the kinetic energy before collision for the neutron and kinetic energy after collision for the neutron. So we can say for neutron, kinetic energy initial will be equal to half m V0 square, and kinetic energy final will be equal to half m, velocity is V1 square, and V1 we already calculated, so half m, and V1 it came out as minus 1 by 3 V0, minus 1 by 3 V0 whole square. So this can be written as half m V0 square multiplied by 1 by 9. So we can say from here that PD is percentage loss of kinetic energy, which will be nothing but kinetic energy is equal to kinetic energy initial minus kinetic energy final divided by kinetic energy initial. So we get PD is equal to, initial is half m V0 square and final is half m V0 square multiplied by 1 by 9, and this is half m V0 square. So this cancel out throughout, so we get this equal to as 1 minus 1 upon 9. So PD, and this comes equal to as 8 by 9. So we can say our PD will be approximately equal to 0.89. This was the first case. Now similarly we are going to solve it for second case also. Case 2, neutron collides with carbon nucleus. So it means this is neutron traveling velocity V0 having mass m. This is carbon having mass 12m and velocity will be 0, and we are going to get this equal to neutron traveling velocity V1, and we have carbon traveling velocity V2. This will be m and this will be 12m. So once again we are going to use conservation of momentum. conservation of momentum. We have mv0 plus 12m0 is equal to mv1 plus 12mv2. This goes away, m and m cancels out throughout, so we get v1 plus v2 is equal to, v1 12v2 is equal to v0. Let us call this equation number 3. And once again, as the in this case also the collision is elastic, so we can say E is equal to 1, which is equal to v2 minus v1 divided by v0 minus 0. So we can say v2 minus v1 is equal to v0. Let us call the equation number 4. So we can use equation 3 and 4 and solve it. Using equation 3 and 4, we are going to get that our v1 is equal to minus 11/13 times v0, and v2 will be equal to 2/30 times v0. And once again, we are supposed to solve it for, you can say, neutron. Therefore, we can say that for neutron, kinetic energy initial will be equal to, once again, half m v0 square, and kinetic energy final will be equal to half 12m v1 square. So this is half 12m, let me write it here. We can write this as half m, and v1 we already know is minus 11/13. So we get this as 121/169. This will be mv1 is our minus 11/13 v0 square. Okay, here we are talking about neutron only, so this won't be 12, this will be m only. So we can write this as half m v0 square, and this will be 121/169. And similarly, we can say Pc, which is equal to percentage loss of energy, which is equal to kinetic energy initial minus kinetic energy final divided by kinetic energy initial. We substitute the values, we get Pc is equal to half m v0 square minus half m v0 square, and this will be 121/169 divided by half m v0 square, and this cancels out, so we get this as 1 minus 121/169, and this will be coming equal to as 48 divided by 169. So you can say Pc will be approximately equal to 0.28. Therefore, we can say that our Pd is equal to 0.89 and Pc is equal to 0.28. And we get this as Pd is 0.29 and Pc is equal to 0.28. So we have option number A is the correct option. Option B is the correct option. Therefore, option B is correct option. This completes the question. Thank you.